We're going to show some characteristics of it. We're going to do an example and a non-example to get super excited. Okay, so the definition says that a relation is a set of pairs of input and output values. What do you think that means? What are input and output values? When we're graphing. You did it on Friday. What is a set of input and output values? X and Y. Take a point. Which one do you think is your input? And which is your output? Boom, that's all it is. It's any set of pairs that are X and Y. Alright, we're going to write down, in the characteristics, we're going to write down 6 characteristics, so make sure that you leave enough space. Are you guys ready? Okay. So what we're doing today, our whole goal is to represent a relation in different ways, and so now we're going to talk about how you can represent it. We're going to do 4 main ones, but there are 6 different ways that you could do it. So there are multiple ways to represent a relation. The first way is ordered pairs. Which is what you usually start with. And that's a set of input and output values, right? Bunch of X's and Y's, and didn't you graph that on Friday? Fantastic. What do you think another way to represent it could be? You've done this before. At least I hope.
No.
You should have done this before. Can you use your brains and think? Or is it early?
It's early.
Okay, well, if I can do it, tater tots, y'all can do it.
We can mark
No.
on our fingers with
You can represent it as a graph. Take a point. Donnie, you're ahead of us. Because when you use slope, that is a function. And we're just doing relations. So a function, they connect with each other, and they have specific things that go together. But a relation is just a bunch of points that hang out. But I like where you're going. All right, so points on a graph. Can anybody think of another way? I can. An input-output table. Do y'all know what that is?
Yeah.
Like an XY table? Hello. Do y'all know what that is? Okay. I've never seen that human before. Hello. Okay. All right, anyway, let's keep going. All right, so we have ordered pairs, points on a graph, input-output table. Have you ever heard of a mapping diagram? Yes, no, maybe so? Okay, well, you'll learn about it today. Can you think of another way we can represent it? It kind of has to do with slope, Donnie, if that helps. But it's a little more general than just slope. What? No. Equations. Are you guys alive out there? It's like I'm searching for lost people off the Titanic. That's what I feel like. And the last way is a sentence. It can be represented as a sentence. So we are going to focus on the first four. This one, and this one, and this one, and this one. And I'm going to show you how to make those. Are we ready to do an example? Okay, so I'm going to show you an example of what a set of ordered pairs would look like. You write a squiggy. And then you write some ordered pairs. So let's say -2, 4, 6, 9, 3, 8, 0, -5. And then you close it with a squiggy and boom, you're done. That's all you have to do. Now, if I wanted to represent that on a table, I'll give you a moment to write that down. If we wanted to represent that on a table, we would write X on the left, Y on the right. And what numbers do you think will go in the X column? -2 and 6. 3, 0. Take a point. What do you think will go in the Y column? Now, does it matter what order they go in? Does it matter what order we put the X's in? Kind of, but not really. It just matters that you match up the X and Y. Does everybody understand that? So you can't put -2 with 0 because that's not an ordered pair. The ordered pair is -2, 4. Questions, comments, gripes, complaints? Alright, a non-example would be X. What do you think this is? What is that called? Look at you go. Take a point.
I don't know.
I don't know what you just said. What do you think this would be called? A 4. Starts with a C. Constant. Take a point. And what do you think 4X would be called? It starts with a T. I don't even know what you just said. T-E. Term. Is that what y'all said? Take a point. Those are not examples of relations. Those are just things chilling, hanging out on our paper. Thought number 7. Give me just a second. So the next thing that you're going to cut out, that you're going to put on 20B, is this sheet right here. I want you to cut off the bottom and then cut on the dotted lines only. So cut off the bottom and then cut on the dotted lines only. The bottom is the whole thing. So the first thing you're going to glue on 20B is this thing. You're going to fold the flappies in. Yo.
Last week I asked if like checking out vomiting counted into exam.
Can you please just cut and fold your flappies and glue them on paper?
I don't want to vomit.
Please don't vomit.
I won't do it in here.
Okay. Then below this, you're going to glue down this guy. So cut off the ends and then glue this. So this is the top of 20B, and this goes at the bottom. Alright guys, remember we need to beat 6 period because they beat y'all last time on cutting paper, so we need to still be better than them. Let's do this. At least on the cutting paper front. Sweet potatoes. It's okay. And if we get done, you won't have homework tonight. Yay. Oh, how funny. No pumpkin. It looks like this. Just cut the edges and glue it down. I don't understand why you're so confused. Are we ready? Are we ready? Are we ready? Oh my gosh. How about now? Oh. There's some in the closet. Half of our videos, that's just chilling, waiting on people to cut. Who has the top to that glue? Thank you. Thank you, Benjamin. Okay, we have to start. We have to do this. I can't sit here anymore. So, ordered pairs. Please open this. What we're going to do is we're going to write words on the left side. We're going to do examples on the inside. Words on the right side, examples on the inside. Does everybody understand how this is going to go? Are you ready, Freddies?
Ready?
Yes, tater tots, you are. You are what I say. And it rhymes with ready. Alright, so we...
Lots of other.
What? What else rhymes?
Steady.
Are we ready, steadies? Is that what you want me to say?
I'd rather be that than afraid.
Alright, so we write sets of ordered pairs in brackets, which is the correct word for our squiggies, but it's not as much fun to say.
Not brackets for the, yeah.
Yeah, but there's different kinds of brackets. With commas. Commas is spelled C-O-M-M-A-S, not comas. Those are two different things. Commas is spelled with two M's. Coma is when...
You are unconscious.
Exactly. Thank you.
And I know my brother.
No. I'm sorry.
He's in it for all of my
Oh.
Yeah, it actually was nice. I slept in his room. I had the room all to myself.
Stop talking, you're not helping yourself.
I had the room all to myself. It was the best.
Okay.
Only you would think that.
In between, here we go. Let's take a sharp left back to math. In between each ordered pair. And what are ordered pairs? You don't know? It is an X and a Y, so you do know. Okay. So we write it as X, Y, and what comes first? Because it's in alphabetical order. Alright, so a set of ordered pairs would look like this. You could have 2, 3. You could have -4, 5. You could have 4, -6. And -5, -3. And do you see how there's commas in between each set of ordered pairs? That's all you gotta do. Super fancy, right? Are we ready for an input-output table? So we're going to use these same order pairs on all of our ways to represent a relation. So this is a relation. And we've represented it as a set of ordered pairs. Now we're going to turn it into an input-output table. And what you do is, I'll leave this open in case we need to see it. Which one is the input? The input is X, good. And the output is, look at you guys go, process of elimination. So we have two types of input and output tables. We have a vertical one and a horizontal one. In a vertical table, is X on the left or on the right? It's on the left. We did that a second ago. And also if X comes first, then it's on the left. X is on the left. On a horizontal table, where do you think X is? It's on the top. Do y'all know what horizontal looks like? Side to side. Where are we?
We're dead.
Well, in a coma?
No, we're dead.
Oh.
We can work for it.
X is on top on a horizontal table. Okay, so let's turn this. Let's do it. What is my first X value? And what's the Y value that goes with it? Look at us go. What's the next one? And look at you go. Take a point. What's the next one? And what's the last one? Dun, 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 dun. That's all you do. And if it's a horizontal one, you do the exact same thing, but it looks like this. So you have 2, 3, -4, 5, 4, -6, and -5, -3. Any questions so far? Okay, so you're going to be able to do this tomorrow without me, right? I mean, this is so complicated. I don't know how you'll be able to function. All right, on a graph, do you start with X or Y? You start with X. Does it tell you to move left or right or up or down? Left or right. And which one tells you to move up or down? Look at you there. Yes. Okay, hold on just a minute. Alright, so this is your x-axis, this is your y-axis. Always make sure that you label them. You would get 2x minus 120 equals 8. It's 8 minus 128. That gives you minus 120. Alright, so let's plot our numbers. How would we get to 2, 3, which is our first one? Right 2 up 3. And I want you to label it 2, 3. Can you stop? Thank you so much. How would we get to -4, 5? 2, 3, 4. And then? Should we label it? What's our next coordinate? 4, -6. So you would go right 1, 2, 3, 4, down 1, 2, 3, 4, 5, 6. And where would -5, -3 be? Why is your stuff not out? You would go left 5, 1, 2, 3, 4, 5, and then down 3. Good. Now, do not connect the dots. 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 Does everybody understand? When it's just a relation, you do not connect the dots. Alright, last thing we're going to be able to get to today is the mapping diagram. So you have an input and output. You line up the x's in numerical order. So it would be -5, -4, 2, 4. And then you do the same thing with the y's. -6, -3, 3, 5. If they have multiple numbers, you don't repeat them. And then you draw an arrow. So -5 matches up with -3, you draw an arrow to it. -4 matches up with 5, you draw an arrow to it. What does 2 match up with? With what? 3. So you draw an arrow to it. And what does 4 match up with? So you draw an arrow to it. And that's how you do input, output, or the mapping diagram. It's a different way to represent a relation. We're going to cover domain and range tomorrow, and then we're going to do an activity and talk about functions. No homework tonight.
Usually whenever you say there's no homework tonight, I usually don't have homework in any